Morning, everyone. So it's Sir Gerald. This is Chem21 Organic Chemistry for second semester of 2021 to 2022. I will be your instructor for this subject. So for today, we will be actually looking into organic chemistry. So organic chemistry, by the way, is it's just another slice of the wonderful world of chemistry. Bakit so wonderful? Because as we may have learned last semester, chemistry actually made up everything. By made up everything, chemistry is visible or chemistry is present when we talk about food, when we talk about the air we breathe, the atoms that made up our bodies. Uh, so this everything is just a combination or a relationship or a bonding of different atoms uh, in different structures or different arrangements. So in that, uh, organic chemistry actually uh, will we will just focus on some certain parts of chemistry when we talk about organic chemistry. So by definition, actually, organic chemistry is just a study of molecules that have carbon in it. Carbon. So, as we may have learned last semester, carbon actually is not that special in any case, but special in a way because carbon actually made up what we call life. So, yung buhay, mga nabubuhay, mostly nung kanilang parts ng katawan nila or parts ng katawan natin is actually made up of carbon uh, with different structures, with different members of the molecules. Okay, so when we talk about carbon, as you may have remembered, carbon actually have an atomic number of 12. Okay. And based on our understanding regarding valence electron, carbon have four valence electrons. In this, actually, if we are to write or we are to construct its Lewis structure, as you may have remembered, there will be one electron here, another electron here, another electron here, and another electron here. So, this valence electrons actually siya yung nagbibigay ng way or siya yung nagbibigay ng ability dun sa carbon atom natin na mag-form ng different types of bonds and structures. By these four valence electrons, these four valence electrons are actually sites for what we call chemical bonding. So in that, uh, carbon can have different combinations or different alterations of different chemicals or atoms or elements that may bond into it. Okay. So when we talk about organic chemistry, we will be dealing with some different types of chemicals. Actually, by chemicals, uh, based on some videos that you may encounter on the internet, there are approximately 16 million types of there's carbon molecules or carbon chemicals. By carbon chemicals, we will be talking about 16 million of organic chemicals. So, masyadong maraming tingnan. Uh, Parang nakakalulang isipin na pag-aaralan natin yung 16 million na yan. But actually, for this course, we will be just looking into some of it. By some of it, we will be developing patterns on how we can look into this organic chemicals, which made up what we call the study of organic chemistry. So in that, in the entirety of the course, we will be looking into some of what we call functional groups. We will be looking into that later. But for each functional group, this functional group actually made it possible to classify our organic chemicals. So for each functional group, sorry, kinuha ako ng AL. For this functional groups, we will be actually looking into the structure of each molecule. We will be then looking into nomenclature. By nomenclature, as you may have learned last semester, this talks about naming. And this is the system on how we will be naming each organic compound. And next, we will be looking into some physical properties aside from the structure of this organic compounds. Proper properties. And also, we will be looking into the reactions. By reactions, these are just not just these are the chemical reactions that involves these functional groups. So, I may have remembered there are actually 14, if I'm not mistaken, functional groups under organic chemistry. So, in each of the 14, or kung gaano man sila kadami, ito yung mga titingnan natin. We'll be looking into their structure. Titingnan natin kung paano natin sila papangalanan. Also, we will be looking into their physical and sometimes chemical properties and the reactions involving this or the members of this functional group. Okay, so in that, let's proceed to the formal discussion regarding organic chemistry. So by organic chemistry, this is actually a branch of chemistry that deals with carbon compounds. So as we already discussed, uh, carbon with the atomic number 12, yun yung titingnan natin, yung ano, yung mga chemistry behind dun sa mga carbon compounds na yan. Wherein those carbon compounds ay nabibilang into different functional groups. Here are some examples of functional groups. We have here the alcohol. Okay, by alcohol, this is actually we have here the carbon compound, which has three hydrogen attached to it and a hydroxide that is attached into it. So this is actually what we call methanol. So here's the basic structure of that organic compound. So basically, kung kayo ay nagbabasa or nakikinig or nanonood ng news, ito yung pumapatay dun sa ilang manginginom sa Southern Luzon, itong methanol na ito. Ito ay kasi ay napahalo dun sa medyo traditional na drink dun na tinatawag ng lambanog. Supposedly ethanol but ito yung methanol. Next, another example is we have here. So we have here our carbon hydrogen group. And we have here our functional group, which is actually nitrogen plus 2 hydrogen, which is actually amine. So we have here that functional group. Okay. So we have here the methyla, met, methylamine, methylamine. Okay. And also we have here another compounds. Also we have here that carbon hydrogen group, and we have there the functional group, which is COOH, or actually what we call the carboxylic group or carboxyl group, and we call this acetic acid. So in here, actually class, we have here three examples of what we call functional groups. So for the first example, we have here the OH. This is actually from the functional groups of alcohol. We have here the amine, and we have here the carboxyl. Okay, so these are just some example of what we call the functional groups. Okay, so by organic compounds, these are from the word itself, organic. When we say organic, it is something derived from life. Meaning to say, when we talk about organic compounds, these are compounds that can be divided into two big groups, the hydrocarbons and the heteroatoms. So, in that, we have here the hydrocarbons, which are strictly carbon and hydrogens only. And also, we have the heteroatoms. These are the groups or the group that contains carbon, hydrogen, and other atoms like halogens. By halogens, it can be chlorine, fluorine, bromine, iodine. And also we have here oxygen, nitrogen, and sulfur. So in that, this is the chart for that. So with this division class, we can actually see that we have here also different divisions under the hydrocarbons and the heteroatoms. So for the hydrocarbons, we can further divide the hydrocarbons into aliphatics and aromatics. So what is the difference between those two? So when we talk about hydrocarbons, these are strictly carbon and hydrogen only. So when we talk about aliphatics, these are just chains of chains of carbon and hydrogen. So one example of that can be, let's say, propane. By propane, that belongs to alkanes. Propane actually also have three carbon atoms, and those three carbon atoms are bonded to each other, and we have their hydrogen, 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 and we have here two hydrogen for this middle carbon, and another three hydrogen for this last carbon. So what is the difference of aliphatics with aromatics? Aromatics basically have what we call the benzene ring, wherein the benzene ring is actually a combination of six carbons. So we can write this as that. So where in each corner of this piatos shape actually have a carbon in it. So we have a carbon here, carbon here, and so on. And each of the carbon have one hydrogen, meaning to say we have a double bond here, and we have an alternating double bond. So when we encounter hydrocarbons that have this what we call benzene ring, whether it has another chain of aliphatics, the organic compound falls under what we call aromatics. We have further discussion regarding this aromatics. Don't worry. So basically, we have here the list of all our functional groups. So we have here the alkane. We have here that is one. We have the alkynes, and we have the cyclic analogs, which these cyclic analogs are just aliphatics that forms what we call the bilog structure or a circular structure. By circular structure, it can look like this. So we have here this compound wherein each corner again has the carbons and hydrogens, which in this cyclic analogs there are no alternating what you call here. This six carbon compound does not have the alternating double bonds, so meaning to say this does not belong to the aromatics. Okay, so going into the heteroatoms, we have here organic compounds with oxygen. So under oxygen, we have here it is one, two, three, four, five, six, seven, eight, eight other groups of organic compounds. We have here the alcohols. These are just alipatics with OH. Right, that may dadagdag lang tayong OH. And for phenols, these are just aromatics with OH. So we have here aromatics plus OH. And we have ethers, wala. Uh, discuss natin yan later on. But basically, these are just aromatics and or aliphatics wherein there is they are bonded to one oxygen, and we have the aldehydes, we have the ketones. We'll discuss that later, but basically for aldehydes and ketones there is one carbon compound that is double bonded into an oxygen. So yun yung titingnan natin later on. And we have the carboxylic acids, the esters, the anhydrides. Also, for the heteroatoms, we have the thiols. For thiols uh, and sulfides, we'll just check it later on kasi magiging masikip na masyado yung screen natin. Also, we have the halogens, we have the organic halides. Basically, these are just aliphatics with different kinds of halides or halogen. It can be, like I said earlier, it can be chlorine, bromine, fluorine, or iodine, and the other halogens. Also, we also have what we call acid halide. Somehow, it is a combination of carboxyls and halogens. Also, for the heteroatoms, we also have organic compounds with nitrogen, which can be amines or amides, and amino acids. We will look into that later on. Okay, so in that, here are some examples of or example for each functional group in this carbon compounds. So let's just first give the formal definition of functional groups. So carbon combines with different atoms to form characteristic structural units called functional group. By functional group, these are actually just this serves as a basis for characterizing or dividing organic compounds into classes. Also, these are sites for chemical reaction, or functional means reactive in any case, and it serves as a basis for naming organic compounds. So basically, as you may have remembered for our first three examples, we have here the methanol, the methylamine, and the acetic acid. All of them contains one carbon, okay? And all of them contains three hydrogen single bonded to the carbon. And for each of those compounds earlier, we have OH, we have NH2, and we have our COOH, which is the acetic acid. So in that, these functional groups, this OH, this NH2, and this COOH characterize this or these uh, organic compounds into different classes or functional groups. Okay, so here are other examples of them. So for alkanes, we have here the general structure or the general formula for the alkane. So we have here the CnH2n plus 2. This has no functional group. Kasi kung makikita natin, wala tayong magiging site for chemical reaction, or wala tayong definite na site for this example. So one example of this alkane is the methane, or this is a major component for natural gas. Okay. Also, for alkenes, we have here the general formula, which is CnH2n. So this is the functional group. So the functional group of alkenes is the double bond This is a site for reaction. So depending on the reaction and the reactants, so, one of this double bond may open up. At least one of them will open up, forming different types of organic chemicals. So we have here one example. Here is the ethylene. This is the raw material for plastic. Okay. So next, we have here the alkyne. So it has a general formula of CnH2 and minus 2, wherein we have for an alkyne, the functional group will be the triple bond. So we have here what we call the acetylene. This is used for fuel in welding. It can also be used for cutting different types of metal. So for the other classes, we have here the aromatic hydrocarbons, wherein we have here, we don't have a general structure or formula. As long as it has this aromatic ring na binanggit natin kanina. As you may have remembered, we have here the double bonds, the alternating double bonds for those aromatic ring. So one example here is the p-silene. For the p-silene, we have here our aromatic ring. We have hydrogens, and we also have two metal groups. And we also have here the alkyl halides. So by alkyl halides, it is we have here a halogen that is bonded to an aliphatic group or alkyl group na tinatawag. So one example here is the metal bromide. It is insect fumigant or yung tinatawag natin pesticide. Hindi na siya masyadong ginagamit ngayon due to its effects sa environment. Anyway, so we have here the aryl halide. Kung makikita natin, meron tayong aromatic ring, and also we have here our halide. So, again, when we talk about halide, this can be chlorine, fluorine, bromine, iodine, or yung next pa na halogen. So for aryl halide, we have here the chlorobenzene. So by chlorobenzene, we have here our benzene, and we have here our chlorine. That is why it is called chlorobenzene. Okay. For the next examples, you may pause the videos kung masyado kayo nabibilisan sa akin. So we have here the alcohol. Again, we have here our alkyl group. By alkyl, that belongs to the aliphatic. Okay. So our functional group will be the OH. So if we have here our ethanol, so this OH will be the site for reactions. Also, we have here phenol. So for phenol, we have here uh, an aromatic group. So as you may have remembered, sorry. So that will be our benzene ring. So benzene ring, then we have here OH. So like this. Like this one. So we have here the aromatic ring and the OH. So one example here is we have the ocresol. Okay, this is actually ocresol is I think a common name. So by ocresol we have here our phenol, and we have here a methyl group. Okay, so we have here ether. Again, we have our alkyl groups here. So we have here diethyl ether by diethyl because we have here an ethyl group, one ethyl and another ethyl. So diethyl plus we have here our oxygen bonded to two alkyl groups. So that's why it is ether. Okay. And for our next examples, we also have the thiols. So by thiols, these are just sorry, may typo. It should be R. Kaya ako nalito bigla. Anyway, when we have diols, these are sulfide compounds, wherein we have here our hydrogen that is bonded to our sulfur. So we have here our SH. So for the sulfides, let me just correct this. So for sulfides, these are just sulfur that is attached to two alkyl groups. So for the functional group, it should be S. So for the examples, for the thiols, we have here the 3-methyl 1-butane thiol. So this is a component for the skunk scent by skunk, yung animal na mabaho sa cartoons. But anyway, totoo yung hayop pa. But anyway, so bakit siya, why 3-methyl butane thiol? So we have here our chain, which is 4 carbon, that is butane. So we have here our thiol, and we have here a methyl. So Y3. So starting from the functional group, the nearest carbon from the functional group. So we have here 1, we have here 2, that's the second carbon. This is the third carbon. So that is why 3 methyl, meaning to say the metal is attached to the third carbon. Don't worry, we will be talking more about this, or we will be discussing this more later on in this course. And for the dimethyl sulfide, so for the dimethyl sulfide, we have here one methyl and another methyl, so that's di. And we have a sulfide, which is a sulfur bonded to two alkyl groups. And you can say we have here dimethyl sulfide. So next, we have here an aldehyde. One example is acetaldehyde. So as you may look into this, we have here carbon that is double bonded to an oxygen, single bonded to an alkyl group, and attached to a hydrogen. This is an aldehyde. So what is the difference between aldehydes and ketones? So for the ketones, we have here two alkyl groups. Okay. So for the functional groups, aldehyde must have the hydrogen, and ketones must be uh, bonded to two alkyl group. So we have here our examples. We have here the acetaldehyde. It is a raw material for plastic. And also this is actually can be also be derived from cigarette smoke, acetaldehyde. Also, we have acetone. This is a polar solvent, usually used to dissolve cuticle or dissolve cutics. And we have here the carboxylic acids. Same system on how we have discussed the earlier functional groups. So for the carboxylic acid, we have here the acetic acid, which is actually the acid in vinegar. For ester, we have here for ester, we have a function alkyl group, and we have another alkyl group here. And for the ester, we have an oxygen that is double bonded to a carbon. Same with acid anhydride. The difference is we have two carbon atoms that is double bonded to an oxygen. And also we have here the acid halide. For the acid halide, these are just carboxyl groups. So we have here the C double bonded to an oxygen and attached to a halogen. So that is our acid halides. And we have here our amides. We have different types of amides. We will be discussing this more later on in the course. But basically, we have here a primary, secondary, and tertiary amide. And also have amines. So we also have the three different types of amines. We have the primary. This is the primary. This is the secondary. And this is the tertiary. Primary, secondary, tertiary. Same with this. This is the primary, secondary, tertiary amides. In that, we will end the discussion for today. So, for your assignment, I will be posting later by 2:30 siguro. Uh, by 2:30, I will be posting your assignment regarding this functional group, and I will be expecting your answers by the end of the week. Bye!